Hello and welcome to this video on basics concepts in kinematics. Now this video will give you a brief overview of kinematics to help you understand concepts such as projectile motion. Now kinematics is a branch of mechanics that discusses or studies the movement or the trajectory of a object. Okay, it discusses basically the movement or the trajectory of an object. It tries to calculate or evaluate things like displacement, acceleration, and velocity of an object. So I will give you a brief idea of what is meant by displacement, velocity, and acceleration before we move on to something which is more important, which is the equations of uniformly accelerated motion. Now, one of the important properties or physical parameters when we are discussing the kinematics of a moving object is the displacement of an object. Now, displacement is a vector quantity, so you must have a magnitude and you must have a direction. Now, by definition, the displacement of an object is the length and direction of the shortest line drawn from its initial position to its current position. So let's take, for example, I have this point A, and I have another point somewhere around here, point B. These points are just points in space, so you can assign the x and y coordinate to these points. Let's say an object moves along this path and eventually ends up in point B. Now, let us suppose that it takes a time of t seconds to arrive, and at time 0 seconds, or at the starting time, the object is at A. At time t, the object is at B. Now, the displacement of the object is just obtained by drawing the shortest line possible from the starting position, which is this point, to its current position, which is this point. I need to give a direction which indicates the direction of motion, that is from A to B. And then if I were to able to get or calculate some way or another the length of this line, so this length gives me the magnitude of displacement. So I have an object that moves from A to B. It takes a very curly path or curly trajectory to get from A to B, but I'm not interested with the path taken. I just draw a straight line from A to B. I need to draw an arrow also indicating the direction of motion. I find the length to give me the magnitude. Another important property of a moving object is its velocity. Now, the velocity of an object is a vector quantity, which means that you need to specify its magnitude or how fast the object is moving, as well as the direction. The direction tells us the direction of motion of the object at that particular time instant. By definition, the velocity of an object is defined as the rate of change of its displacement. The velocity of an object may be instantaneous at a particular time or an average value of velocity. Now, I'll just explain to you what this means. Now, let's say, for example, we have at time t equals to, let's say, 2 seconds or 2.0 seconds. Let me be a bit more specific here. 2.0 seconds. The velocity of the object is given by 5.0 meters per second. Let's say west. Now, what it means is at this particular time of 2 seconds, the object has a speed of 5 meters per second and is moving west. So it's heading westwards. Now, the velocity of an object could change if its magnitude changes. Okay, it could also change if its direction changes. Now, I'll give you as a slide or small homework. Try to find out what is meant by the term of average velocity. Another physical property of a moving object is its acceleration. The acceleration is defined as the rate of change of velocity, and it can be calculated by using this particular formula, which is given as a equals to v minus u over t. Now, what you have to be mindful is this velocity, this v, will be the velocity at time t. So v is the velocity at time equals to t. Which t is it referring to? This t corresponds to this particular t here. This u is the initial velocity. This initial velocity will be at t equals to 0. Be mindful that this equation only works if your acceleration is uniform. Uniform is a fancy word for constant. So now we have arrived at the last section of this video. The last section of the video basically analyzes three equations of uniformly accelerated motion. Now, uniformly accelerated motion is a fancy word that means constant acceleration. So when we're dealing with the object or an object that is moving with a constant acceleration, we are allowed to use this particular three equations. Okay, now if you don't know by now what v, u, and a and t stand for, let me just give you a brief overview what v, u, a, t, and s represent. So basically, t measures time, v is the velocity of the object or at time t, u will be the velocity at time 0, which means u is the initial velocity of the object. A is the acceleration. For this case, it has to be, or it must be constant. And of course, s is the displacement of the object at t, at time t. Now, be also mindful that these equations are vector equations, so they are very, very direction sensitive. What it means is, let's assume I have a straight line. Oops, let me make this line straight. And I have an object that starts from this position. This object is free to move along this line, so you can move to your right. You can also move to your left. So we have two different directions, right, left. So in terms of vectors, right and left are opposite directions. So if you take to the right as positive, to your left will be considered as negative. So when it comes to velocities and displacements, you have to be very mindful of the sign that you plug in into your equation. So let us just go through the first equation, which is v equals to u plus at. Let's analyze this equation a little bit. Now, if you deal with constant acceleration or uniform acceleration, if you were to plot a graph of velocity on the y-axis or on the vertical axis against time on the horizontal axis, you will get a straight line which may or may not pass through the origin depending on the initial velocity. So what u represents here, u actually refers to the velocity at t equals to 0, at time 0. V represents the velocity at t. So this is a straight line, and the acceleration from its definition is the rate of change of velocity, which also can be obtained from the gradient. So for this straight line, the gradient of the graph gives you the acceleration. So if you were to work out the gradient of this graph, you will actually have an equation in this form: v minus u over t minus 0. Now, what you have to look out for is this is the velocity at this particular time, and this is the velocity at this time. Okay, now if you do simple algebra, you will find that this equation simplifies into the more popular form of v equals to u plus at. Okay, then let us now look at how we can actually derive this particular equation: s equals to ut plus half at squared. Now, s represents the displacement of the object after time t. So s refers to the displacement of the object after time t. Now, if you have uniform acceleration, and if you were to plot a graph of velocity against time, or velocity versus time, you'll find that you obtain a straight line, and this straight line intersects u on the vertical axis. Now, if you were to calculate the displacement, all you need to do is find the area under the curve from t0 to time t. As you can see, I've indicated the area under the curve as a trapezium. Okay, it'll be a trapezium, and I've broken up the trapezium into two parts, one which is a triangle and one which is a rectangle. The triangle is in red and the rectangle is in blue. So I'll calculate the displacement by just calculating the individual areas of the rectangle first, and then summing it up with the area of the triangle. So what I'll have as the area of the rectangle is just u times t, okay, which is length times width, and I add it to the area of the triangle. Okay, the area of the triangle, I need to get the base, which is t. Okay, I'll probably write it down here because it's in red. And then the height of the triangle is given by v minus u. So area of a triangle is given by half times base times height. Now, I'm almost there, but the only issue I have is I have this term v, which I don't have in the equation that I'm about to derive. So I need to figure out how I can eliminate this v. Now, if you recall, the acceleration is given by v minus u over t. So therefore, v minus u is just equal to a times t. Now, what I have here is I have a v minus u here, and I have, okay, just let me rewrite this down here. So I'll get wrong color. So I'll get v minus u equals to at. So I have a v minus u here, which is also equal to at. So I can just substitute this in here. So that will give me s equals to ut added to half t times at. And we are there with this equation. Now, just to elaborate a little bit, the displacement, or s, is the displacement at time t. So it's the displacement at this particular time. in this particular time too. Okay, so because displacement is time dependent, it depends on time. Okay, by hook or by crook, we have arrived at the last equation. Now let me attempt to derive this particular equation. Now, as you should recall, the displacement at time t is just given by this area which I've shaded using yellow ink. So now displacement is given by the area of the rectangle plus the triangle. But instead of this approach that was used in the previous slide, I'm just going to use the area of the trapezium. You should recall that the area of the trapezium is given by half times the height of the trapezium times the sum of lengths of the parallel sides. Okay, so what it means is for this particular trapezium, I'll need the height, which is t. The length of this parallel side is v, and this parallel side is u. Because this side and this side, they are parallel. The length of one is u, the length of the other is v. The distance between the parallel sides is t, which is the height. And so my displacement works out to be half times t times u plus v. Now the thing is, in this particular equation, which I'm boxing in yellow, there's no t in it. So we need to figure out a way to get rid of the t. You should recall that the acceleration is given by v minus u over t. Therefore, t is given by v minus u over a. So what I'm going to do is just plug in the value of t as v minus u over a, and I'm going to rewrite this as v plus u. Alright, now if you were to expand this, you will just get v squared minus u squared over 2a. And what you can do is first multiply both sides of the equation by 2a, and that will give you 2as equals to v squared minus u squared. And what I need to do next is add u squared to both sides of the equation. So that will just give me v squared equals to u squared plus 2as, which is the equation that I needed to derive.